guys, welcome. Let's calculate the inductance and resonant frequency of our homemade FM radio transmitter, and then check out how a square wave produces harmonics in multiples of the original transmitted frequency. So here's our transmitter, and you can hear the tone that we're transmitting today coming off this 555 timer chip right here. And that sound that's coming through the 8-ohm speaker is being picked up through this lead coming off the LM386 amp module. That's acting as our receiver antenna right there. And there's our antenna coming off the transmitter. So just to give you a heads up, that's the signal we're transmitting today, and we no longer need the amp module. It's handy to use the amp module though when you're troubleshooting getting your transmitter going. So it's quiet right now, but that transmitter is transmitting the signal. Now check out my previous video on how to set up the transmitter with the inductor coil and the transistor with the oscillating circuit. And I've got a schematic here. Just to quickly review there, you've got your NPN transistor. There's the LM386 amplifier right here. The signal in is coming from our 555 timer as mentioned, and the oscillation is taking place between ground and voltage in two areas right here, and that's interfacing with the base of the NPN, and over here. Ground and voltage in are connected by a 22 nanofarad, that's 223 capacitor. So this is the oscillation portion, all going through this NPN transistor. We've got a 10 picofarad connecting the emitter with the collector on the NPN. That's the feedback capacitor. We have our inductor coil. I'll give you a little close-up of what those look like. Refer to my previous video, please. I'll put a link in the description how to make these coils. Today I'm using a 4-turn coil instead of a 5-turn. And so that's right here, and that's going into the collector of the NPN. And then we've got our tank circuit. Bring this down a little bit. We've got our tank circuit capacitor right here, which is a 10 picofarad value today. And that goes into the power rail on one side, and it interfaces with the inductor, as you can see here, and the antenna, which is this twisted copper wire right here. It works perfectly well. Either apparently solid or braided twisted wire seems to work equally as well. So before moving over to the software-defined radio program GNU Radio Companion, let's calculate the inductance of our coil and then calculate the frequency that we'll be transmitting at in megahertz. So you want to measure in inches the diameter of the coil and also the length of the coil. And that's going to get plugged in your inductance in microhenries formula here. Diameter squared times the number of turns. This is a 5-turn, however we're using a 4-turn coil today. So the diameter squared times the number of turns squared divided by 18D plus 40 times the length of the coil, again in inches. Well, I've got 4 turns, a 10 picofarad tank capacitor. The diameter is 0.125 inches, the length is 1.875 inches. So plugging that into our inductance formula, the inductance on the coil on board the transmitter today is 0.0256 micro henries. And then we can plug that value into the frequency formula, the resonating frequency formula. And following through here, we're actually going to come up with 1 over pi, which is an interesting value. So we should be transmitting in the 318.3 megahertz. Now you're going to get a decimal value from this. Just carry that over to the thousands place, and you're going to get your megahertz. Now, before we turn over to the software-defined radio program, what's interesting is that I'm picking up all kinds of harmonics here, you'll see, and I've made some notes previously about where I'm picking up harmonics in the signal. The 555 timer translates as a square wave, and square waves produce harmonics, and they produce harmonics in multiples of the original transmitted frequency. So let's check it out. Framing the shot here, I've got the Realtek 820T2 USB software-defined radio dongle and its antenna. And I've got the transmitter transmitting right there in the corner, just a few feet away from the antenna. But you'll see in my previous video, that's transmitting at least up to 25 feet. And then over here, we've got GNU Radio Companion loaded up and ready to go. GNU Radio software-defined radio program. Really great modular tool with a tree layout and format. I've done videos on this on the past. I will post links in the description into how to get started with software-defined radio. And let's fire it up. We've got the FFT plot here, Fourier fast transform plot. And we'll just go right around to the 318 range and see how close we are according to our frequency resonation, our resonating frequency calculation that we did previously. And we can see it on each edge there. We've got a 2 megahertz span here. So I'm at 318 right now. And I'm already seeing activity, so that is pretty cool. There we go. There's our 555 timer chattering away. Bringing it a little closer here. It's actually going to be closer to, make it 316.85 right there in the center. Cool. So that should be our original frequency. Now let's check out some of these harmonics. One thing I'm noticing, and again I was checking this out before doing the video, and I'll just show you here that I'm picking up harmonics every 80 megahertz. And we should have our next one right around 400. Yep, you can hear that's 396. Can kind of just adjust this parameter here. And subtracting about 0.4 of a megahertz should bring us right in the center. Nice. So yeah, I mean, if we're picking that up at 317, we should just be under 400 megahertz, and we are 396.4. And I've found these elsewhere, also around 240, 160, and 80 as well. So guys, thanks for watching. It's a lot of fun to check out the harmonics of a saw wave that you're transmitting yourself with a homespun inductor coil. And checking out GNU Radio Companion, software-defined radio. Subscribe to my channel, share it with your friends, and we'll see you guys real soon.